One of the areas of geometry that you'll frequently get into is called solid geometry. And I'm going to start with just a geometric shape called a cube. A cube, think of it like an ice cube. It's equal on all sides. And here they've shown a visual representation of what a cube is. And if you go down here a little bit, it gives you the um, volume, the surface area, the radius, the area, this sort of thing of a cube. If I look at it as a geometric object, uh, it yields things such as the formula for the area, which is right here, the surface area, the width, and the depth. The surface area says 6s squared. Well, that makes sense because you know that the area of a rectangle is length times width. And since in a cube, the length and the width are the same, so if you look at just this face, it would be length times width, they're the same, so call it s squared, s times s. And there's 6 faces. There's this top face, this front face, a side face, a face on the other side, a face on the back, and a face on the bottom. If you flattened that all out, you'd have 6 faces, and they're s times s, or s squared in area. So the area of this is naturally 6s squared. So you'll have formulas for the cubes. You'll also notice here this thing called vertices, edges, and faces. This actually gets you into another domain of mathematics called topology, very advanced collegiate mathematics. Vertices, it says there's 8 of them. Well, there's a vertice here, where lines intersect 1, 2, 3, 4, and then there's 4 down at the bottom. 1, 2, 3, 4. There's 8 vertices. Faces, we've already been through. There's 6 faces on each side of this object, and there's 12 edges. And edges are intersection of a line. So there's a line that's intersected with these 2 points, a line that's intersected with these 2 points, a line that's intersected with these 2, and a line there. There's also a line intersecting up and down and crossing both the bottom and the top face. And those are the edges. And there's actually formulas for vertices, edges, and faces in topology called Euler's method, which is very advanced mathematics. But the point here is cube. Well, let's make the cube, instead of the side being 1, which is what it's assuming here, let's let the size equal to 3. So cube with each side equal to 3. This side is equal to 3, that side's equal to 3, that side's equal to 3, this side's equal to 3. Then what is the volume, the area, that sort of thing? You put that into Wolfram Alpha, it comes back and says, okay, you've now got an edge length of 3, calculates the area for you, which is 6s squared. So 3 squared is 9, 6 times 9 is 54. That's what the formula gave you before. So that's an example of geometric properties using geometry in solid geometry with just a simple cube. You could likewise get into cones, pyramids, spheres, and go through the same process and learn everything you wanted to know about spheres. And this has actually introduced you to vertices, edges, and faces, which is topology. Another mathematical domain for another day, or feel free to explore it.